Hi students, this is 2.3 special products of polynomials. Please make sure you write this down, name, date, period on the upper right hand corner. Our essential question for today is, what are the patterns in special products? So I basically went through the textbook, and I believe there's like a little cutout. If not, I will upload this on Google Classroom for chapter 2 printouts if you can. If you can't print it out, then I would like you to write it down in your notebook on the side. Okay, so example 1 says find each product. And what's happening here is when you're looking at, when you're multiplying, because that's what product means multiplication. We're looking for patterns, and this basically will cut down some time. If you're not comfortable, now this is a cool thing about, these special products. If you're not comfortable, there is another way that we can go about solving or finding each product or multiplying binomials, which we just finished that section. We went through the distributive property, the FOIL method, and the box method. But just finding special products will cut down your time, and it will also help you when you enter Math 3, which there are more special patterns. There are more patterns that you want to look at. Okay, so basically what we're doing is, if you have an addition sign here, I'm looking at the first pattern, square of a binomial sum. That means that addition is occurring here. And what's happening is that we're squaring the first term, which is x squared. That's here. You're squaring the last term, which in this case is b squared. I'm looking at the pattern, so it'd be 7 squared. And the middle term, which is the 2ab, you're taking that 2 and you're multiplying it by a times b, which is x and 7. So you're multiplying all of that. So what does that look like? Let's write that down. I'm actually going to cover this for now. This is a distraction. Okay, what does that look like? It looks, you can write it out, and it looks like this. We're squaring our first term. Okay, we're squaring the last term, which is 7 squared. Now, the middle term, we're multiplying it by 2 times, and you're going to multiply the 7x. Okay, and that will give you x squared plus 14x, because 2 times 7x is 14x, plus 14? No. 7 squared is not 14. 7 squared means 7 times 7 is 49. Okay. And there's your answer. Now, if you're like, I don't know, Mrs. Holmes, I don't know about these patterns, it's going to take practice, but you can always check your answer. If you're not confident or comfortable, use the box method, x plus 7. There's 2 of them. That's what this squared means. There are 2 of these binomials. And what you could do is just create the box. X plus 7 here, x plus 7 here. You multiply 7x, multiply, you end up with 7x and 49. Okay, looks like we're on the right track. Remember, you can combine terms, and I'm actually going to combine them. X squared, 7x plus 7x is 14x plus 49. Isn't that what we got, students? Okay, so this is just, you're using patterns of special products. Okay, now what happens if there is a negative? Okay, we call that square of a binomial, but it's the difference of the two. And there is going to be a negative there, so... Oh, we're going to do one more. Sorry. Okay. So again, we're squaring this entire thing. That means, according to the pattern, we're squaring a. A is this entire expression right here, 3x. So we're going to square the 3x. And we're going to square the last term, which is 4x. I'm sorry, 4 squared. And we're going to double this. We're going to multiply it. Plus 2 times 3x times 4 is 12x. Okay. Now, what does this mean? This does not mean 3x squared. We have squared here. We have parentheses. That means that this square, this exponent, needs to be applied to both the 3 and the x. So 3 squared is 9. X squared is x squared. Now let's go ahead and multiply 2 times 12x. That gives us positive 24x. 4 squared is 16. And there's your final answer. Again, if you're not comfortable with the special products or special patterns, you can fall back on the box method, FOIL method, etc. Okay, let's throw in a negative. So now we're looking at the square of a binomial, the difference. And that means that there's a negative. It looks like it's the exact same thing. There's only a negative here. So we're going to square the first term. We're going to square the last term. Again, that's going to be positive. The only negative is going to be the middle term, and it's 2 times the 2 terms. So we're going to multiply these 2 terms and then multiply it by 2, a negative 2, sorry. So let's set it up. So this is going to be 2x squared. We have plus, remember this is going to stay positive, plus 3 squared. And then we have a negative, negative 2 times 2x times 3 is 6x. Okay, so let's go ahead and distribute this 2 into the parentheses. Remember, it's going to be applied to the 2 and to the x. So that's going to make it 4x squared. Multiply these two, minus 12x. 3 squared is positive 9. Please do not give me 6. It's 3 times 3, not 3 times 2. Okay, so I put a star next to this one because it is a little tricky. You have to remember that there's a negative there. Again, you can fall back on the box method. Okay, so example 2 is going to ask you to find each product. Okay, you can use the FOIL method, the box method, but take a look. Take a look at these because we have, they kind of look the same. One's positive, one's negative. So if I'm looking at this and I have one positive, one negative, what does that mean? It means this. If you have a plus b and a minus b, so one's positive, one's negative, your final answer is going to be a squared minus b squared. Okay, so what happened to the middle term? The middle term was canceled out. Well, before I actually write out this pattern, I am going to set this up here real quick. And I'm just going to use the box method because I still don't understand what's going to happen. Okay, so we're going to use the box method. And I'm going to show you if you have x plus 3 and you have x minus 3, if it's just separated by a positive and negative, let's see what happens. X times x is x squared. We end up with 3x, a negative 3x, and a negative 9. Okay, so what do you notice, students? What do you notice right here? The answer is, you notice if you have a positive 3x and a negative 3x, these terms are going to cancel out. So that's what they're talking about. The middle term gets canceled out, always. Final answer is x squared minus 9. And that's what they're talking about right here. You're going to square this first term, which is x squared, and you're going to square this, the last term, which is, and you're going to keep the negative, it's minus 9. Okay, so when you see a positive and a negative of the same thing, students, you can't have a 2 here and say, oh, it's positive and negative. If this has a coefficient of 2 and this does not, then you're simply going to have to multiply. Use the box method, FOIL method, rainbow method. But because they're very similar and one's positive, one's negative, Okay, what you can do is you can actually multiply x times x is x squared, and you can multiply the first and the last terms, because we know, we just proved that the middle term is going to get canceled out. And this gives us -9. So you are able to do that as long as you are comfortable with the pattern of this special product. Okay? All right, same exact thing's going to happen here. We have a positive and we have a negative. Everything else is the same. Then we can use the sum and difference. We can use the pattern that we just did in the previous one. We can multiply these two. Again, you're multiplying 3x times 3x, which is 9x squared. And you're going to multiply y times a negative y. And that's going to give you -y squared. Again, notice how the middle term is not there. It's canceled out because of the plus and the minus sign. Okay? All right. Moving right along. Example 3. It is going to ask us, and I believe this is our last example. Fantastic. It's going to ask us, factor the expression using the GCF. Well, what is the GCF, students? GCF is greatest common factor. Let's write that down. Greatest means largest. So we want to factor out the largest common factor, the largest number, the largest expression that they have in common. That's what we want to factor out. Okay. Okay. So you're looking at the 4y and the +8. You can start out with 2, but there's something even larger than 2 that you can factor out. What is it? It's 4. We can factor out a 4 here and 4 here. So you take that 4. If you take it out, how do I get from 4 to 4y? We have a y here. How do I get from 4 to 8? That's a +2. You could double check your work and say 4 times y is 4y. 4 times 2 gives me +8. We're factoring out the expression using our greatest common factor. Okay. All right, fantastic. Excuse me. Okay. And let's do one more. 3x plus, this is going to prepare us for the next section, I believe. Or chapter 3, I can't remember. 3x plus 27, what does the 3 and the 27 have in common? 3. So take out that 3, what's left on the inside of the parentheses. How do I get from a 3 to 3x? Multiply it by x. How do I get from a 3 to 27? Multiply that by 9. Double check your work. 3 times x is 3x. 3 times 9, 27. There's your answer. Okay, thank you.